Chapter 5, Describing Distributions Numerically. So we're going to talk a little bit today about box plots. All right, so the first thing that we're going to do when we talk about a box plot is we're going to talk about the 5-number summary. So what is a 5-number summary? A 5-number summary is basically a glimpse as to what the data set is all about. So if you were to actually read a book, and you would open up the front cover, or you would look at the back of the book and you would read the little summary, it would give you a glimpse as to what the entire book is about, right? So you wouldn't have to read all 300 pages, you could just read it and you could get an idea of what it is about. Well, that's kind of the same way about a 5-number summary. So a 5-number summary is for a data set. So this is 5 numbers that are going to give you a glimpse as to what's going on with the data so that you don't have to look at all 500 pieces of data or 100 pieces of data. You can just look at these 5 numbers and they're going to give you a good picture as to what's going on. Okay, so they are positions in a data set that give us valuable information about a data set. So the first one is the min, and that is the minimum data value or value in the data set. Then we have Q1, which represents the lower quartile. Then we have the median, which is our middle number, if the data set is arranged from smallest to biggest. Q3, which is the upper quartile, and then we have the maximum. So Q1, which is the lower quartile, that actually represents the bottom 25%. So let me push my little pin. This is going to represent the bottom 25%. Or you can also say that this is equal to the 25th percentile. So the median, which is the middle, this is going to be the 50th percentile. And then we also have Q3, which is the upper quartile. So this is going to be your top 25%, right? Or this is also called the 75th percentile. So when you're talking about percentiles, remember that's a percentile to the left. So if you're in the 75th percentile, that means then you're better than 75% of the rest of the people in the data set. Okay, so let's kind of look at the graph below, which is a box plot. If you look at this very bottom piece, this is 59. This would be our minimum. And then 64.5, this would represent Q1, which is our lower quartile. 66 would be our median. And then 70 is going to be Q3. And then this top value right here is going to be our maximum. So those 5 values are going to give you the 5-number summary, and then from there you can make a box plot, and then that gives you a graphical summary of your data set. All right, so here is our box plot, right? So it says that a box plot is a graphical version of the 5-number summary. So this is just, again, a graphical picture of what we just talked about. You can see that, we have the minimum value down here. This is our min. We have Q1 is here at the corner. Then we have the median, which is the middle. Q3 is the upper corner. And then last, we're going to have our maximum, which is at the top. So again, just another graphical representation of the 5-number summary, which is the box plot. Okay, so the next thing that we have with the box plot is we have some terminology that kind of goes with it. So the first thing that we have is what they call an IQR, or an interquartile range. Interquartile range is found by taking Q3 minus Q1. So this means that you're going to take, the top quartile, the upper quartile, minus the bottom quartile, and that's going to give you the range. Well, that range is actually this box right here. So this yellow box is our IQR, which contains the middle 50% of the data. So if you notice that a box plot is divided up into quartiles, right? We have our bottom quartile, the bottom 25%. Then we're going to have our middle one, another 25%, then the next one 25%, and then our top 25%. So the two middle boxes, they represent the interquartile range, is our middle 50% of our data. Okay, so a whisker contains the upper and the lower 25% of the data. So this right here is our upper whisker, and this one is our bottom whisker. So how it works is when you draw the box plot, you're going to draw it, the box, which is the interquartile range, and then you draw the whisker out to the maximum value. So you would kind of draw it, like this. And then you're going to draw the whisker out to the bottom, to the minimum value. All right, so calculating outliers, right? If a data value is above the upper bound or below the lower bound, then it is considered an outlier. Okay, so how are we going to determine if something is above or below the upper bound or the lower bound? Well, we actually have formulas that are going to help us figure that out. So the first formula is for the upper bound, which we're going to take Q3 plus 1.5 times the IQR. Then, if we want to calculate the lower bound, we're going to use Q1 minus 1.5 times the IQR. So with those, that's going to tell us that anything above the upper bound is considered an outlier, and anything below the lower bound is going to be considered an outlier. So if you look at this picture, it's going to be of a box plot. So with the box plot, this one will, it shows you here's the median, right, which is our middle. Then right here, we're going to have Q1. And then this one, which is the 75th percentile, this is Q3. And then it shows you these little lines right here. So you have to kind of like envision some sort of like imaginary fence. And anything above the imaginary fence or below the imaginary fence is considered an outlier. So it's, kind of looks something like this. This is our imaginary fence that we have going through. So anything outside of the imaginary fence on either end, below it on this side or above it on this side, these are all considered outliers. And we're going to actually draw the outliers as kind of, sometimes they put them as stars, instead of these circles, because the circles, they kind of like mix in. So you can put them on the calculator, like sometimes they're going to have a feature where you can make them as like a dot, or you can make them like a square or something like that. But anything above or below that is considered an outlier. So when you're actually drawing this, right, it depends on how you're going to draw it. And we'll talk about that in just a little bit. So a modified box plot is going to be one in which you're going to show an outlier as that little star that I was talking about, or you can make it the box or whatever you want, but you're going to actually show it as a piece of data, okay? And then it says for a modified box plot, if the outlier exists, the whiskers are drawn depending on what's given. So there's a couple of ways that you're going to draw the whiskers. So the first way is if you have data. Okay, so what does that mean if you have data? That means that you're actually have all the different points listed. You were not just given a 5-number summary. You were given all 300 points or all 20 points or all 5 points or whatever. And then you're going to draw the whisker to the next data value that is not above or below the upper or lower bound. Okay, you are going to put it to that value, and then that's going to become where your max and your min are. Okay, so then if you have a 5-number summary, you're going to draw the whisker to the upper or the lower bound. Okay, so if you have the data, then it goes to the next data value that didn't jump over the upper or the lower bound. If you have a 5-number summary, you don't have the data value to look at, so you have to use the upper bound and the lower bound. All right, so here's a picture of the modified box plot so you can kind of see how it looks. So here is our box plot, and you can kind of tell, right, that here is the maximum value right up here, and then the outliers are marked with the asterisk. So then you can see that the minimum value on this side, and then we're going to have the asterisk over on that side. So the only difference between a regular box plot and a modified box plot is that the modified box plot is going to actually have the outliers drawn with the little stars. They will actually tell you on the AP test what they want you to do. Like, they will tell you to make a modified box plot, or they're going to say that you're going to do a box plot and make sure that you show outliers. If they don't say, then you can just create a regular box plot. All right, so let's look at the box plots and how we can determine what the shape is of our box plot. Okay, so when we had a histogram, we could look at it and we could say, oh, it's either skewed left, skewed right, or so forth. Well, these are also going to have shapes, and so sometimes it's kind of hard to look at these versus looking at, a histogram. So what are we looking at? We're looking at this middle line, really, which is our median. Okay, and if we took and we drew the curve over the top of it, you can see that it's pretty symmetric. So this would be a symmetric distribution. So if we looked at the second one, again, this line right here is our median. Okay, and if I drew a curve over it, it's going to kind of go up and then it's going to fall to the left. Okay, so this one is going to be a skewed left distribution. Now, it's kind of odd when we look at it because our median is pulled more towards the right-hand side, but you have to think that this is where the majority of your data is on the right-hand side, and it's going to fall to the left. Okay, so then skewed to the right, this one, same thing. We're looking at our median, which is right here, and then we're going to take and we're going to go up, and then we're going to fall to the right. So this is basically what you're going to do is when you have to look at them and you have to describe what the distribution is, it's easiest if you kind of envision putting some sort of a histogram on top of it so that you can determine what the actual shape is.